Today, most important question of Aras Agarwal in three-dimensional geometry, unit the plane, exercise 3C, the last question here, question number 12, very important question. Question is here, find the vector and Cartesian equation of the planes. Find the vector and Cartesian equations of the planes which are at a unit distance from the origin to the planes. Vector r dot I minus j plus 6 is equal to 0 and vector r dot 3i plus 3j minus 4k is equal to 0. From the intersection of these two planes, the planes, so many planes passes, the planes which are at a unit distance from origin, we have to find that plane. Equation of any plane through the intersection of the planes, vector r dot I minus j plus 6 is equal to 0 and vector r dot 3i plus 3j minus 4k is equal to 0 each. From the intersection of these two planes, equation of any plane is vector r dot I minus j plus 6, vector r dot I minus j plus 6 plus lambda, vector r dot 3i plus 3j minus 4k is equal to 0. Where lambda is useful? Equation of first plane plus lambda into equation of second plane. This is the required equation of a plane passing from the intersection of these two planes. Solving it, we get vector r dot I plus 3 lambda I common, 1 plus 3 lambda I minus j plus 3 lambda j common, minus 1 plus 3 lambda minus 4 lambda k plus 6 is equal to 0. It is the required equation of that plane. Equation number 1. Equation 1 is the required equation of that plane which passes from the intersection of these two planes. And now, since required plane, this plane 1 is at a unit distance from origin 0, 0, 0. The distance of this required plane from origin is unit. Hence, distance using distance formula, 0 into 1 plus 3 lambda plus 0 into minus 1 plus 3 lambda plus 0 into minus 4 lambda plus 6 upon a square root 1 plus 3 lambda whole square plus minus 1 plus 3 lambda whole square plus minus 4 lambda whole square in mod. Since distance can't be negative, it is 1 unit. It is given 1 unit. 0 plus 0 plus 0 plus 6 upon a plus b whole square 1 plus 3 lambda whole square, so 1 plus 6 lambda plus 9 lambda square. Minus 1 plus 3 lambda whole square, so 1 minus 6 lambda plus 9 lambda whole square, plus minus 4 lambda whole square, so 16 lambda square, mod is equal to 1. Now squaring both sides we get 6 square of 6, 36. Squaring a square root deleted. Plus 6 lambda minus 6 lambda I can see. So 1 plus 1, 2, 9 lambda square plus 9 lambda square plus 16 lambda square, that's 34 lambda square. It is equal to 1 square to 1. By cross multiplication, 1 into 2 plus 4 lambda square, 34. So 2 plus 34 lambda square is equal to 36. Take 2 right side. 34 lambda square is equal to 36 minus 2, 34. Lambda square is equal to 34 divided by 34 to 1. Therefore, lambda is equal to the square root of 1, the plus minus 1. Lambda is equal to the square root of 1, that is plus minus 1. Putting value of lambda plus 1 once and minus once next. In equation 1, required equation of plane, we get vector equation of required plane which passes from the intersection of these two planes are, to putting lambda is equal to plus 1 in equation 1 here, and lambda is equal to minus 1 again in equation 1. We get equation of required plane in vector form. So it is vector r dot 1 plus 3 into 1, so 1 plus 4, 1 plus 3, that is equal to 4i, minus 1 plus 3 into 1, so 3, minus 1 plus 3, 2j, minus 4 into 1, so minus 4k, plus 6 is equal to 0. Vector equation here, vector r dot 4i plus 2j minus 4k plus 6 is equal to 0. Dividing by 2, we get vector r dot 2i plus j minus 2k plus 3, it is equal to 0. Now putting lambda is equal to minus 1 in equation 1. Lambda is equal to minus 1 in equation 1, we get 1 plus 3 into minus 1, the minus 3, 1 minus 3 is the minus 2i, minus 3 up minus 1, the minus 4j, and minus 4 into minus 1, the plus 4k plus 6 is equal to 0. R dot minus 2i minus 4j plus 4k plus 6 is equal to 0. Or vector r dot dividing by minus 2 we get. So dividing by minus 2, it becomes I plus 2j minus 2k minus 3, it is equal to 0. So r dot 2i plus j minus 2k plus 3 is equal to 0 on one plane 1, and r dot I plus 2j plus 2k minus 2k minus 3 is equal to 0, second plane. There are two such planes which passes from the intersection of these two planes and are at unit distance from origin. It is a vector equation. It is a vector equation of that planes. Now, Cartesian equation of this required plane are, so here vector r, instead of vector r, we put xi plus yj plus zk. Putting vector r is equal to xi plus yj plus zk, we get vector r and xi plus yj plus zk dot 2i plus j minus 2k plus 3 is equal to 0. I dot I 1, 2 into x to 2x, I dot j 0, I dot k 0, j dot I 0, j dot j 1, the 1 into y to y, plus y, j dot k 0, k dot I 0, k dot j 0, k dot k 1, the 1 into minus 2, the minus 2 into z, the minus 2z, plus 3 is equal to 0, plus 3 is equal to 0. 2x plus y minus 2z plus 3 is equal to 0 is the Cartesian equation of plane 1. And here putting, we get r dot I plus 2j minus 2k minus 3 is equal to 0. So instead of r, we put xi plus yj plus zk. xi plus yj plus zk dot I plus 2j minus 2k minus 3 is equal to 0. I dot I1, 1 into x plus I dot j 0, I dot k 0, j dot I 0, j dot j 1, so 1 into 2 into y, so plus 2y, j dot k is equal to 0. Now, k dot I 0, k dot j 0, k dot k 1, so 1 into minus 2, the minus 2 into z, the minus 2z, minus 3 is equal to 0. Hence, those equations of planes, and in those planes which passes from the intersection of these planes, which passes from the intersection of these two planes and is at unit distance from origin, in Cartesian form are 2x plus y minus 2z plus 3 is equal to 0 and x plus 2y minus 2z minus 3 is equal to 0. Thank you and have a nice day. Please subscribe the channel and write your comment in each video. Thank you.